The next step is assessing the model fit. Often the identified models do not fit the data. Therefore, we require to assess the model fit. We have two classes of fits, the absolute fit and the relative fit. Within these two classes, we have different fits that are commonly used in SEM. The absolute fit indices are the fit indices that looks at the ability of the model to reproduce the observed covariance matrix, whereas the relative fit indices compares the theoretical model specified to a base model. This baseline model assumes no relationship between variables. Examining fit indices are very important in SEM analysis. They are useful in testing certain types of hypotheses, especially comparing alternate models. Important types of absolute fit indices. So now let's look at the important types of absolute fit indices. The chi-square value. Chi-square value looks at the hypothesis that the observed and implied covariance metrics are equal. We require the significance value to be greater than 0.05. The non-significant chi-square value indicates that there is very little difference between the observed and the implied covariance metrics. It is important to note that the chi-square value is sensitive to sample size. With large sample size, small differences between observed and implied covariance metrics becomes quite evident. Therefore, chi-square value shows good fit for small samples compared to large samples for the same covariance metrics. Thus, in addition to reporting chi-square value, it is required to look at other fit indices as well, such as the RSMEA and the GFI. The root mean squared error of approximation looks at the average size of the residual. The smaller values of RSMEA represents better fitting model, and it provides confidence intervals in significant test. Though the values less than 0.1 are acceptable, but we require values less than 0.05 to conclude that the model is a good fit. The goodness of fit index values that are greater than 0.9 are considered good fit. It is required to look at all the fit indices together rather than looking at each value independently. The second class of fit indices are the relative fit indices. As I pointed out earlier, these fit indices compares the theoretical model specified to a baseline model. These fit indices tests if the model that we have specified is better than the model where there are no relationships specified. The commonly used relative fit indices are normed fit index, incremental fit index, and comparative fit index. For all these fit indices, the values range between 0 to 1, and in general we require values greater than 0.9 for all these fit indices.